Hello, my name is Aaron Grassa. I'm with Team Mantis Shrimp. Our sponsor for the year is Lucid Agency, which is right off of Mill Avenue, and we worked with them this year to create a web application now known as Lucid C. In this video, the team and I will go over how we developed the application and what we learned from it.
Elizabeth Coppinger of the web marketing business Lucid Agency asked our team to develop a seating chart application for our Capstone project. We developed the web application hosted at https://lucidseat.com. The web application should allow employees of a corporate office to make a profile and then add preferences like noise level or how close they want to be to the restroom. The application should then take all the employees in the office and, using their preferences, map them to seats on the floor plan. The main motivation of this project is to address the problem of seating a large amount of employees in an office setting. As the number of employees in the office grows, the more burden is placed on the office manager to ultimately seat employees together. Currently, many office managers simply group teammates together without considering preferences. With a large number of employees in an office, it can be hard to maximize these employee preferences. By maximizing these preferences, it's more likely that the employee will be more productive. This project should automate the seating chart process for an office manager so that they can generate seating charts quickly and then quickly adjust them when the employee preferences change. Currently, there are a few seating chart applications available. Most of them are simple seating charts for classrooms. They tend to have a simple drag-and-drop interface and let users add names to seats manually. More advanced seating chart applications, like the one shown at the bottom right, have additional design features like different table shapes, but still require seating individuals manually. These designs do not automate the seating chart process, so they are not efficient or scalable when the number of individuals becomes large. There were a number of objectives for this project. Employees should be able to create profiles to add their preferences. Thus, a login system needed to be implemented to allow them to register with the application. The system needed to implement offices and office managers so that they could create floor plans for an office. By using the office employees, their preferences, and the seats in the floor plan, the resulting seating chart should run quickly and seat employees in such a way that it optimizes employee satisfaction by meeting as many employee preferences as possible.
Hi there, my name is Jeff. I'm a member of the team and I'll be talking about our project architecture. So starting off, let's talk about some goals that we had for the design. So I have 3 listed here. The first goal that we have is split up work into smaller components. So the idea behind this was, instead of thinking about our project as one big application, let's think about it as smaller systems that work together to solve the problem. Doing so would allow us to work more concurrently, meaning that we could either be working on different parts of the same code base or be working on completely different code bases altogether. It would also allow us to work more independently, meaning less meetings, more flexible schedules. Another goal that we had was to limit the amount of ramp-up time needed for tools and technologies. So the thought behind this goal was let people choose technologies that they're excited about, let people do what they're good at, and put all of the team members in a position for success. And then the last goal, more abstract, just we want an effective design. We want something that promotes modularity and loose coupling and that satisfies all of our constraints and requirements. So here you can see our high-level architecture in drawing form. So you have the server on the left, client on the right. So looking at the server, you can see that we have a MySQL relational database, and we have a Node API that's communicating with that database. And within the Node API, we have our seating assignment algorithm, which is written in Java. So that's a completely separate component. It's invoked by the Node API. Moving over to the client, you can see that we have an AngularJS single-page app. The Angular app is responsible for all of our web user interface except for seating chart creation, which is delegated to the seating chart builder, which uses some different technologies. So every design has benefits and drawbacks. Some benefits of our design were that it did achieve most of those aforementioned design goals. We were able to separate our app into smaller components. We were able to work concurrently, independently. Another benefit was that we employed universal JavaScript. We had JavaScript we were using JavaScript for both our server code and our client code, which meant that for a lot of us, instead of having to learn 2 languages, we just had to learn 1. And there were drawbacks as well. So single-page apps are more complicated than using something like Rails or Django or Laravel. That's just the nature of it. It's just a more sophisticated way to build a web app. But there's a UX trade-off because since more of the code is executed on the client, more of the code is snappier and faster, and it means less network requests, so better performance. Another drawback of our application is when we separate our app into smaller components like this, it is good, but then when at some point we have to bring them back together, and sometimes you encounter unforeseen problems when this happens. So our classic example was when we had to integrate the seating chart builder into the Angular app and also communicate with the Node API, then invoke the Java algorithm. It's just until you actually do that, there are problems that you're not going to run into. So those were some main benefits and drawbacks of our design.
Hi guys, my name is Alan Kawanzaro, and today I'm going to talk about technologies that we use for our application. So we use Node.js for the backend, MySQL for our database, Java for our algorithm, Bootstrap, React, and Angular for the front end, then Postmail for sending emails to. So here is an overall picture showing you how our application works. We have Nginx proxy accepting requests from the user and redirecting those requests to either API or the front end. And we see our API is written in Express.js, which is a Node framework. And this Express.js either invokes our Java algorithm or calls our MySQL database or calls services online using cron jobs. So the service that we use online is Postmail. It's used for sending emails to our users. Then at the front end level, we have our Angular front end and also our Redux React application builder app. And on the Angular front end and Redux React, both in both applications we use Bootstrap to style our application. Since security is the most important thing in a web application, we also implemented it on the backend level. We use JSON tokens, JSON web tokens to authenticate users. Then we also implemented a permission level based access. That is like giving user different sets of permissions. We also let the RESTful API handle most of the employee management functionality, and that helped encapsulate most of the business logic from the client. We also had different cron jobs that automated services, such as sending emails and send notifications to users and admins.
Some of the decisions we made over the course of development significantly impacted the project. One of the biggest decisions was to go with Node.js instead of Spring. We decided to do this for a lot of reasons, but more importantly because the process of setting up Spring was taking too long. Whereas with Node, we already had a member who had experience with it and was able to set it up within a day or so, which got us rolling on development much quicker than Spring did. Another key decision was to use React for the seating chart builder. We were choosing between Interact.js and React and decided to go with React because members had more experience with it and it was more fluid than Interact was. A decision that may have had the most impact would be the decision to make the application as secure as it could be. We realized that anyone could make API calls without the proper permission levels. To fix this, we surrounded most of our API with token security, which disabled outside users from making malicious API calls, and also disabled users from accessing APIs they had no permission to use, which made the application safer and much more robust than it previously was.
Hi, my name is Jack Bankston, and I'll be going over some of the lessons we learned during this project. The first thing we learned is how important it is to have well-made plans and designs. This makes for a smoother process than having to make major design changes midway through. We learned that in general, when picking a framework for our project, it's easier if we can agree upon a well-known one. This makes it more likely that a large portion of the team will be familiar with it already, and for those that are not, the more well-known it is, the easier it will be to learn about it online. We also learned how important it is to make sure our understanding of the requirements always matches up with what the customer, which in this case was our sponsor, is looking for. We found that real user data was one of the most useful tools we could have in order to create test cases and generally better understand the problem we were trying to solve. We learned that we shouldn't be afraid to incorporate new technologies or switch what we're using altogether if that will help us solve a particular problem. We also found that you have to plan for scalability instead of trying to focus on it later on in the project. And lastly, we learned how important it is to stick to deadlines as much as possible in order to stay on track overall.
At the end of development, we accomplished most, if not all, the requirements that Lucid gave to us. Let's start with the employee management side of the application. Here's a login page where all super admins, admins, and employees will log into to view their accounts. So let's log into a super admin to view their side of the application. So all users will be sent to their profile to edit and view it. As a super admin, you have access to all pages and accounts on the website. This is mainly for management of the site, so we'll hand this off to Lucid Agency when we're done with the project. So let's look at the seating chart application of it. Here, this is where all the floor plans are. You can view, edit them, design them, or delete them. You can add conference rooms, desks, kitchens, and restrooms to each of the floor plans and add walls by clicking these spaces. When you're done with it, here, let me just add some more stuff just to show that it works. When you're done, you can save the design. Floor plan data has been saved. Hit done. You're sent back to the floor plan, and it's now saving what you put in before. Once that's finished, you can go to seating charts, and that's where you can add the seating chart. Let's do a new design. Video design. You can select the floor plan. So since we edited test, we can do that, create the seating chart, and the seating chart has been created. In conclusion, as a team we accomplished the final goal of the project, which was to create a functioning web app that fulfilled Lucid's requirements. We'd like to thank ASU and SIDSI as well as Lucid for being a fantastic sponsor. Thank you all.